Hi, this is Dr. S and welcome to video 11 of my series on aromatic chemistry for OCR A-level. In this video we're looking at phenols, which are compounds that have an alcohol group, an OH, directly attached to an aromatic ring, so to a benzene ring. So here are 5 compounds. What I'd like to do is look at the 5 compounds and decide which one is the odd one out. 4 of them are phenols, 1 of them is not. So pause the video, have a look and try and decide which one does not fit. Okay, so I said that a phenol is one where the OH group is directly attached to the benzene ring. So here, the OH group, you can see there's a bond from the oxygen to the carbon of the aromatic ring. So that is a phenol. In fact, that is just called phenol. I'll come to the naming of the other 4 shortly. This one, you can see that the OH group here, again the oxygen is directly attached to the aromatic ring, so that is a phenol. This one, OH group, oxygen directly attached to carbon of a ring, that is a phenol. Here the OH group is not directly attached. The oxygen is attached to a carbon that is not in the ring, so this is not a phenol. Here there are 2 OH groups, OH group here, OH group here. This one is not directly attached, but this is part of a carboxylic acid. This is an alcohol group directly attached to the benzene ring, so this is a phenol. So let's look at how to name the other 4. As I said, this is just pure phenol. When we get onto naming phenols, the OH group takes precedence in the name, so that comes at the end of the name, so it's based on a phenol. And we can name the substituent groups before that in the name. So here, if this is phenol, that becomes carbon 1. So counting around to get the lowest number, the methyl group is on carbon 3. So it's 3 methyl phenol. Remembering we're counting to get the lowest number, and here it doesn't matter that the OH group is not at the top, I will automatically start counting here because that's where the phenol is. In this one, this is your phenol group. Now it's worth noting that this one looks backwards, doesn't it? HO rather than OH. That's because the oxygen is the atom that's bonded to the ring. So the correct connectivity is to draw it backwards. You'll see that on the left hand side of the benzene rings. So this is the phenol, so that is carbon 1. If you then count around, 2, 3, 4, 5, and that would be 6. The methyl groups are on carbon 3 and carbon 5. So 3, 5, dimethyl phenol. Okay, this one is not actually a phenol, so the phenol will not appear in its name. However, we should be able to name it based on what we've learnt from previous videos. This is one of the strange ones where you've got a phenol group as a substituent, because it's really hard to name otherwise. So this is actually based on ethanol. This is an ethanol piece here. So this would be phenyl ethanol, and actually it would be 2-phenyl ethanol. The reason it'd be 2-phenyl is because the ethanol is the basis of the name, so that carbon there is number 1 of the ethanol, and this is 2. And the phenyl group is on 2. Okay, this is a difficult one to name because we don't have the name in the A level of this group as a branch. So that means we have to not call this a phenol, but we use this as a hydroxy group. That's an alternative way of naming an alcohol. So here, actually this section here is called benzoic acid. The benzene with the carboxylic acid directly attached to it is called benzoic acid. So that means here I have a hydroxy group on carbon 3. Although it's called 3-hydroxybenzoic acid, it is still a phenol. It's just that's the easiest way to name it. Okay, so now I'm going to give you a chance to practice. I'm going to put 6 compounds on screen. I'm going to ask you to try and name them. So pause the video, have a look, try and use what you've learnt, and then come back when you're ready. Okay. So there are different skills needed in over these 6. So we need to look for the phenol group first. So in this one here, this is the phenol group, so that's the basis of the name. So that becomes carbon 1, 2, 3. There is a methyl group on carbon 3. So 3 methyl phenol, which actually is the same as one of the ones I had on the previous screen, but it just looks the wrong way around. It's still 3 methyl phenol. Go here. The OH group is your phenol, so that becomes carbon 1. That's carbon 2. So 2 chloro phenol. Here, this is your phenol, so that's number 1. And then you need to count either way around to get the numbers, so I'll go this way around. Doesn't really matter, because you'd get the same numbers anyway. I've got 2 methyl groups, one on carbon 2, one on carbon 6. So 2, 6 dimethyl phenol. Here, this is your phenol group. So remember, this looks backwards, but it's still your phenol group, so that's still number 1. 2, 3, 4, 5, 6. Yeah, so 2, 6 with 2 methyl groups. Oh look, it's just exactly the same as the last one. But the fact that it's rotated, a lot of people wouldn't spot that they were the same compound. If you take this one and rotate it anti-clockwise, you actually just get this. Okay, this one, this is your phenol here. So that's number 1, 2, 3, 4, 5, 6. 3 chloros on 2, 4 and 6. So 2, 4, 6 trichlorophenol. And this bottom one, here's your phenol group here. So we'll count from number 1. Again, it doesn't actually matter which way around you go because it's symmetrical. So 1, 2, 3, 4, 5, 6. We have a chloro group and some methyl branches. Well, chloro comes before methyl alphabetically. So it's 4 chloro, 3, 5 dimethyl phenol. Okay, and remembering your rules of naming, between a number and a letter you have a hyphen, and between 2 numbers you have a comma. Okay, good. Now this is a good point to look at what we actually use phenols for. Phenols are quite good antiseptics, and these 2 are actually commercial antiseptics that you might be familiar with. This one here, 2,4,6 trichlorophenol, can be shortened to TCP, which is an antiseptic solution that you can buy in the shop. Here, 4-chloro-3,5-dimethylphenol, it's not shortened, but this is the active ingredient in Dettol. So the antiseptic surface spray. So they will kill bacteria. Okay, so in my next video, what we'll look at is the reactions of phenols. Okay, I'll see you then.